In this video I'm going to be looking at the solution to question 5 of the June 2011 Edexcel D1 paper, and the topic of the question is route inspection, or the Chinese postman problem. The question talks about figure 5, which is shown in the paper, and says it models a network of gas pipes that have to be inspected, the number on each of the arc representing the length in kilometers of the pipe. The route of minimum length that traverses each pipe at least once and starts and finishes at A needs to be found. We're asked to use the route inspection algorithm to find the pipes that will need to be traversed twice, and making our method and working clear. Having done that, we need to write down a possible shortest inspection route giving its length. The question then goes on to say that it's been decided that we can start the inspection at D, and we can go along each pipe finishing, or we must go along each pipe rather, finishing at any other node. So we then need to determine the finishing point so that the length of that route is minimized. Well, the first part of the question then is a standard sort of question for this topic of route inspection. So the first thing to do is to identify the odd nodes that we have, and we can see that the odd nodes are at A, at D, at F, and also at C. So the odd nodes, we need to state them to make our method clear, are A, C, D and F. So pairing these together, there are three possible pairings: AC together with DF, AD together with CF, and AF together with CD. And we need to look at the minimum distance between each of these. Well, from A to C, clearly that's 9. That's quite straightforward on the diagram. From D to F is actually D to G to F. And it's worth keeping a track of that because it will be important later on. So from D to G to F, and that's 13. So in total, that gives us 22 kilometers. In a similar way then, AD is actually ACD, which is equal to 16. Notice that you need to be careful there from A to D. It's not the direct route from A to D, but you do need to check that there is if there are shorter routes. In this case there is. From A to C to D is 16, whereas AD was 17. So do be careful and don't assume that because there's a direct link from A to D that that's necessarily the shortest. From C to F, the route is CEF, and that is of length 8, giving a total here of 24. And from A to F, the actual route is ACEF, A to C to E to F, and that is length 17, whereas from C to D is 7, so giving again a total of 24. The shortest, or the minimum value, is here at 22, and therefore we need to repeat those arcs. And the arcs that we need to repeat are AC, and then DG and GF. So 3 arcs to be repeated. So the total there of those arcs is 22, so we can work out that the length of the route will be a total of 98 plus 22. We were told that the 98 was the total weight of the network, so the length there will be 98 plus the 22, or in other words 120 kilometers. The actual path, well, there are many different paths through this, starting and finishing at A. one way to do this is to mark in those ones that we're going to repeat. So let's put them in from A to C. Just change the color of my pen. We're going to repeat from A to C here. So I'm just going to dot that in. And we also need to repeat DF from D to F. That's D to G. And from G to F. So those are the ones that are being repeated. Now we need to go over each of those arcs once. There are in total, if you count up the number of arcs, there are 13 plus 3 repeated. So we've got 16 arcs in total. So 16 arcs, that's 13 arcs plus 3 repeats. And if there are 16 arcs, there must be a total of 17 nodes. So a check you can do to make sure you've got a root is to make sure you've got 17 nodes. Now, as I say, there are many different ways of doing this. One way is to start with A and then work round in one direction, for example, sort of in an anti-clockwise direction, basically working in that fashion towards the middle. Sorry, beg your pardon. Round in anti-clockwise direction, and then working to the middle where necessary. So I'm going to start doing that, going from A to D, and then coming into the middle part, C, and then back out to G, and then doing this loop from D to G, and then we can go from G to E, back out to the middle, from the middle, round the loop, and then coming down to B. Then we can see we've got to go to E, to C, back to B, then to A, and then we've got to go around this loop again from C, and finally back to A. So if you work systematically, then you shouldn't get into too much of a mess. So that's one particular example that I've just done. Another one, a slight variation, is as follows. It goes A, D, C, A, C, G, D, G, F, G, E, C, B, E, F, B, and A. So make sure that you have starting and finishing in A and a total of 17 nodes. Okay, so that finishes that part of the question. The marking for it was as follows. There was an M1 mark and then 3 A marks for this first part of pairings. So as long as if you've got 1 correct, you've got 1 A mark, 2 correct, 2, and finally for all of them correct, 3 A marks, depending on how many of these were correct. For writing down the repeats, there was an A mark, and that was a follow-through mark. So if you had made an error in your calculations, then that mark would be given on your values. And then finally 2 marks, B1 and B1, for calculating the length of the root and actual value of the root, or the actual lettering of the root rather. In the next part of the question, there's a slight change. We're told we can now start and finish at D. Now the relevance of this, of course, is that D is an odd node. So if we start at an odd node, we need to finish at some other node. though, we can start and finish at our odd nodes. So we need to join together two of the others. Now remember that those others were F, C, and A. So we need to look at the possible pairings of those to see which root we need to repeat. Well, in fact, although you might at first glance think, okay, it's going to be CA, it's not, because C to F is actually a total of 8. So the smallest pairing of the other ones is from C to F, which is length 8. And so therefore we can finish at the other node that we're not using, which is A. And we're going to repeat FE and CE. The length of the root, well, we've got the 8 for our repeats plus the 98, so the length of the root is now 98 plus the 8, which is 106 kilometers. The marking in this part of the question was a method mark for realizing that the odd node meant that you could pair two others together, that you're starting and finishing at odd nodes. An A mark for getting the shortest and therefore finishing at A, and finally an A mark there for the length 106. Well, that completes the solution to this question. You'll find solutions to other questions at www.furthermaths.org.uk.